Okay, so I would like to get started on section 1.4, problem number 40. Alright, so the given information is the half-life of radioactive cobalt, which is 5.27 years, so 5.27 years. So that's given information. And initially, we have at the level of 100 times the level acceptable. Alright, so that's that. Then we want to go back to the acceptable level. Right, so since we can think of this as a decaying exponential function, so the let's say amount of cobalt after t years, let's call it function c of t. Then you have initial value, so initial amount would be, I'm going to call it the c sub 0. Then you have e to the right? Since it's decaying, so we're going to have a negative exponent, negative kt. Here we have that. Alright, so this is the exponential function for the amount of radioactive cobalt after t years. Right, so we know that after 5.27 years, we know that it's going to be the half of the initial amount. So from there, we can get this information. C of 5.27 years, all right, will give you 1/2. But first we plug in, say C of 0, e to the negative k, then t is 5.27, right? And this has to be equal to, since it's a half-life, so it's a 1/2 of original amount C0. Alright, so from there we can actually solve for k. So here what we can do is we can divide both sides by C0, so which means you can cancel those. Right, which gives you e to the negative k times 5.27 is equal to 1/2. Alright, what we're going to do is I'm going to actually solve for the e to the negative k. Right, I would try to isolate that instead of solving it all the way to k. So all you really have to do is raise both sides to 1 over 5.27 power. So we're gonna raise both sides to 1 over 5.27 power. So which you're gonna get e to the negative k is equal to 1/2 raise it to the 1 over 5.27 power. Alright, so this is great because you can put this guy and back in here, right, which we already know. So therefore we have function c of t, right, which gives you let's say C0 is still unknown. Actually, we don't really have to know, so that's whatever the amount, the 100 times the acceptable level. And e to the negative k would be just we just found that the 1/2 to the 1 over 5.27. Alright, then you can raise it to the t, so you put t here. So this is the function. Alright, so the question is asking for the for the time it takes to go back to the acceptable level, and currently it's 100 times the acceptable level. So what you need to do is we can set up the equation c of t is equal to C0, then you have 1/2 to the t to the 5.27, and we have to set that equal to, so our level is going to be 100th of the current level, so we to go back to the acceptance level, so we're going to have to set that to 100th times C0. Then can you find the value of t from there? Alright, so that's kind of how you start the problem. Alright, I hope this was clear.